All right, hello everyone, and happy Friday. Kind of a gloomy, rainy Friday out there this week, but gloomy, rainy days are good days to stay inside and talk about code. So let's go ahead and hop into Studio 2. This is one of my all time favorite studios. I like both. There's two parts, and I like both of them. They're both just kind of really cool, interesting problems. The first problem that we're going to be talking about is called Gambler's Ruin. That's a very famous problem. I actually have been getting into gambling a bit myself these days. Going to the casino can be a fun activity. But, in this simulation, we're trying to be a professional gambler and make some sort of estimate about whether it's going to be, in our best interest to go to the casino and play under certain conditions. So, we're going to do this in a couple of different ways. We're going to simulate gambling, so literally simulate the act of going to the casino and gambling money over and over and over again and just see how the numbers work out. And we also have some math equations that we can use to help us as well, and we'll kind of compare and contrast those two different versions. What we're ultimately, trying to figure out is what's a good win limit for us? When should I stop playing, basically? Go to the casino, I win X amount of dollars, and that means I should go home. What is X? That's kind of what we're trying to figure out, is how much money should I, take as a successful day and go home. And then also, this is another question that I'm, interested in figuring out. How often should I expect to lose all my money? Because that's going to happen sometimes, right? The luck's not always going to go in your favor. Even if you think you have an advantage, it's not going to be 100% guarantee that you're going to win money at the casino. Some days you're going to lose money. That's just how it works. So how often should I expect that to happen? That's good for me to know so that I can try and absorb those losses and tell myself it's just part of the plan. It's just part of the way that gambling, being a professional gambler works. So the first thing we need to do, we're going to set up our simulation. We're going to set up the simulation that goes to the casino, and plays games at the casino until, we either win all of our money or we lose, not win all of our money, we lose all of our money, or we win some set amount. So I'm going to go ahead and create a new class here for us to work in. We'll call it simulation, I guess. That's fine. Oops, I forgot to put in the main, so I'll just go ahead and type that out real quick. I often forget to do this. You could also copy it, from another file. If you forget to do this yourself, you can always go copy it from somewhere else. And the instructions have us start out by reading in a few different values from the user. So we want to know, how much money do we start with? How much money are we going to the casino? What is the chance that we're going to win? So how often do we think we're going to win? 50% would be, flipping a coin, heads or tails. Obviously, casino games are varying in how much they offer you a chance to win or more realistically lose your money, right? And then this is our win limit. This is one of the values that we're trying to figure out and that will, kind of vary over time to see how it affects our win rate. So let's go ahead and start by using Scanner to read in these three values. I'll go ahead and put in a scanner for us now. By now I feel like most people are getting used to this idea of putting scanner in and then using print statements to print out the prompt. What's the first value? I already forgot what the first start amount, win chance, and win limit. Let's do it. The starting amount is going to be a figure of dollars, right? So probably, I think for the sake of the game, they say that we're either going to win $1 or lose $1 every time. So the number of dollars we have is always going to be a whole number, which means I could use an integer for it. Start amount. There goes our integer. And then I'll copy this whole thing 2 more times and just kind of tweak it for the other 2 values. So the second value that we need is called win chance. Now this is a probability. Probabilities are typically represented as a value between 0 and 1, which will actually come in handy for us a bit later when we get to the simulation part, as you'll see. Win chance is going to be a double. Notice how I just modified the existing line to suit my needs. That's good programming. It's good programming technique. Win limit. This is the amount where, you know, if I go to the casino and I earn this amount of money, then I'm going to leave and say that was a successful day. So win limit will also be an integer. So that's a pretty easy one to set up. And now we are ready to start the simulation itself. We are going to start by simulating a single day. So we're going to write code that will repeatedly play the game until we either hit our win limit or lose all of our money. And the trick, the trick here is to think about how often we'll need to play, or how many times we're going to need to play. We have two ways of approaching repetition, right, in our code. One of them is to use a for loop, and the other way is to use a while loop. In many situations, they can be used, interchangeably to do kind of the same things. But in this particular situation, I think a while loop is going to be the better choice, and that's because there's a degree of luck involved. There's a degree of chance involved. We're about to use some random numbers to help us simulate, gambling at a casino. So I don't know how many coin flips it's going to take to lose all my money. I can, make some estimates, but until I actually go in there and flip the coins, right, I have no idea how many times I'm going to have to do that before I lose all my money or hit the win amount. So in this particular situation, I think a while loop is the best tool for the job. Later on, maybe we'll see a situation where a for loop might be a better pick. But for now, let's figure out how to state our conditions. I want to keep playing while I have not hit the win limit. So while my starting amount is how much I walk in with. So the starting amount is either going to go up as I win or down as I lose. So I'm going to keep playing while the start amount is greater than 0 and while the starting amount is less than the win limit. Think about how I wrote this out. There's an and in the middle. That means both the left-hand side and the right-hand side must be true in order for this loop to run. So I'm saying that in order for us to take a pass through the loop and keep playing at the casino, we need to have positive amount of money, right? We need to have money left. The casino won't let us play if we don't have any money. And we also need to have less than our win limit, because if we hit our win limit, then we want to stop playing and go home. So there we go. That's going to take care of our while loop conditions. Now we need to simulate playing the actual game itself. And in order to do this, we need to generate a random value and compare it against our win chance. So, let's go ahead and grab a random value first. I'm going to keep it simple and just use math.random. Consider that math.random is going to give me a value between 0 and 1 that actually corresponds very nicely to the win chance, which is going to be a value between 0 and 1. Think if the win chance is 75%, right? Math.random gives me a value between 0 and 1, so anything less than 0.75 would be a win if the win chance is 0.75. If the win chance is 25%, right? Math.random gives me a value between 0 and 1, so anything less than 0.25 would be a win. Anything greater than 0.25 would be a loss, and it would give me the proper ratio of wins and losses. So in order to write this, we're going to use an if statement to compare our random value against the win chance if the random value is less than the win chance. You could say equal to as well. In fact, I think that might be slightly more accurate, although it doesn't make a huge difference in the number of games you would win or lose, just a very small one. Then, this means we win. And I might even put a comment out here, or even a print statement. You win, right? And in order to represent that win, I'll say start value needs to be increased by 1. We win $1. We have won $1. Oh, it's start amount, not start value. Sorry. There's our winnings. If the random value is not less than or equal to the win chance, that means we have lost. Notice I don't actually have to state that. If I use an else statement here, then the way the computer reads that is it will check this. If that's true, it'll do this. Oops. If that's true, it'll do this amount of stuff. Otherwise, it jumps down here and just does whatever's in the else. So I'll go ahead and put in a print line to say that we lost. And I'll reflect that by taking $1 away by using start amount minus minus. So at this point in time, we're about at the place where we can test this out. I'm just going to put one more print statement down here after the loop to say the day is over. Just to indicate that we have either won or lost a significant amount of money and are going home. So let's try this out. Let's go ahead and try this out and see if it can properly pick whether it is properly gamble, properly simulate winning or losing. I'll start with $100. Whoops, haha, I got a little sloppy, didn't I? I forgot to change the prompts. They all say start amount. So I got a little surprised when I saw that. Let's go back and fix it. It's a common mistake. Win chance is what this one should say. And finally, this one should say win limit. All right. I'm going to start with $100. I'm going to say the win chance is 50-50. This would be flipping a coin, right? And the win limit will be 200. So I'm just trying to win. I'm trying to either win $100 or lose $100. And based on what we see here, right? You can see that, wow, it took a lot. It took a lot to either win or lose, which is kind of what you would expect, right? At 50-50, it would kind of vary a lot, but it looks like ultimately we did lose and we went home after we lost all of our money. Let's try this again. I'll start with the same amount, but this time I'll make the win chance significantly higher, make the game pretty generous. I'll make it 90%, and the win limit I'll keep the same at 200. And now we can see that, unlike last time, it took much fewer trips through the loop, right? Many fewer trips through the loop. I'm winning very frequently, so I hit my win limit pretty quickly, and don't have to go play the game as long to make that desired amount of money. Okay, but let's keep going. This is just meant to simulate a single day, but we want to become, professional gamblers. So we're going to keep going back to the casino day after day after day, and trying to play. And we want to see how this will add up over time. One day is not really long enough to know if this is going to be profitable for us. We need to know if this is going to work over months, over years worth of play. So we want to do this entire day's amount of work a whole bunch of times. And specifically, we're going to come up here, we're going to ask the user how many days they wish to simulate. I believe the instructions tell us to call that total simulations, all right? Total simulations. And I'll call this total simulations. And this number is how many times we want to do this. So we want to do this whole chunk of code this many times. And so again, this is an act of repetition, right? So we have that same question that we had earlier. Should we use a while loop or a for loop? And while loops are great when we don't know how many trips it's going to take to get us through. So it really depends on a lot of factors here, right? Depends especially on the win chance. You saw that, the chance really affects how many trips it takes to go through the loop, how fast I win or lose money. But this time I know exactly how many times through the loop I want to go. So I want to go total simulations number of times. So a for loop is going to be the better tool for the job. And a for loop, remember, has 3 parts. The first part is the loop variable initialization. The second part is the condition under which the loop will continue to run. And then finally we have an update statement. I misspelled this. There we go. So I'm saying I want I to start at 0 and I want I to go until it is less than, strictly less than, but not equal to total number of simulations. So if the total number of simulations is 10, then I would go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it would stop. So that's actually 10 times through the loop, especially if we start counting at 0 like I've done here. This is a pretty common way of setting up our loops. The brackets need to go around this entire code section, right? So let's go ahead and put the brackets down here, and you can see the indentation's not quite right, so I'm going to do Control A, Control I. That will fix all of that indentation for me without me having to do it manually. Now we can see that I have a loop within a loop, right? This loop is going to tell this loop to keep going over and over and over again. And this should hopefully simulate us going to the casino over and over and over again, day after day after day. Now we do want to print some extra information. We want to print the day number, the number of plays that took place, and then whether the day ended in success or ruin. So let's go ahead and add that in before we try this out and see what happens. Here is where I know the day is over. Notice that I'm still inside of the for loop, right? But I'm outside of this while loop. So this while loop is really what's simulating one day, and then this for loop is simulating that one day over and over again. We need to print out some more information. I wanted to know what the day number was. All right. So actually, I'll just stick that right in here. I'll say day I is over, right? So it'll just substitute the value for I in every time it goes through the loop. Then I need to print out the total number of plays that took place that day. I'm not currently tracking that, but I could, right? The number of plays is gonna, so let's go up here and make a new variable, right? Int number of plays equals 0. And then every time I play a game, or every time through the loop, it doesn't matter if I win or lose, the number of plays is going to go up. So really, I could put this in a few different places, and it would be correct. I might put it right at the very beginning. Number of plays plus plus. Add 1 to the number of plays. Doesn't matter if I win or lose, I'm playing the game. And now when I get down here after the day is over, I should be able to print out what that is. Okay, there we go. And then I think the last thing that it wanted was whether I ended in success or ruin. So we just need to compare the start amount, right, against either 0 or the win limit. It'll be one of those two values. So if the start amount is equal to 0, oops. Does it have, oh, it does have an example run. Yeah, simulation 1, simulation 2, simulation 3. Okay, gotcha. It has it all on one line. I spread it out across multiple lines. That's okay. I'm not too worried about the format as long as we can understand it. Why are you, oh, I have an extra parenthesis there for no reason. Else ended in success. Okay, let's give it a shot. I'm going to go ahead and try this out. Run the program. I'm going to use the numbers that it tells us to use. The start amount of 2, win chance of 7, win limit 10 for 500 total simulations. So these are pretty small stakes we're talking about. We're going to start with $2. We have a 70% win chance. That's actually pretty good for us. Our win limit means we're going to go home if we ever get $10, and the number of simulations we want to do is 500. So here we go. Well, notice I'm off by 1. If I really wanted to, I could, you know, use some parentheses here to add 1 to I, so that that's not off by 1. If I scroll up to the very top, it'll say that I started at day 0, right? But actually, scrolling up to the top kind of shows me that there seems to be a problem here. Every day looks to be going exactly the same, and that's not really what I would expect, right? I would expect there to be some variance over time, some differences. So I'm a little bit confused as to why that happened. I mean, I think I set this code up somewhat properly, but let's try and figure it out. Let's try and figure out what happened. Let's try and figure out, you know, where the mistake has been made. I'm going to use the debugger. I'm going to step through the debugger and go through the simulation and just kind of see if it's acting the way I would expect it to act. So I skipped all this scanner stuff. I'm not really worried about whether that's working. I think the problem's down here somewhere, so I set my breakpoint on line 20. I'm going to hop into the debugger. Type in our starting amounts, 2.7, 10, and 500 total simulations for us. And now we've hit the breakpoint, so now we can actually see all of our values over here, and we can watch them as we go to the casino and we gamble. So let's step through the code and watch the simulation in action. All right, I'm about to begin day number 0, or day number 1, I guess, depending on how you look at it. The number of plays goes up by 1. I choose my random value, which looks to be like a winner. Great. All right, I'm going to play again. Number of plays goes up. I get another winner. That's great. I'm up to $4 already. Oh, whoops, I lost that time. So I'm just going to keep playing here. I'm either going to get up to 10 or down to 0. Let's see what happens. Oh, I'm winning. Start amount is up to 9, so if I win one more time, that'll do it for me. And, oops, that's the loser, so we got to keep playing. Oh, back up to 9 again. Let's see. This time we hit a winner, so I should be done after this with the first day, right? And there I see my start amount is in 10. That's in yellow there, so that should trigger this while loop to quit. Let's make sure that happens. All right, there it goes. So far everything's working the way I would expect. It prints out the information. Day 1 is over. I played 12 times. That looks to be correct. I ended in success. That's also correct. So now we should start over again and do day number 2. Here we go through the loop. We're going to try and do day number 2 now. And I expect it to start simulating, and it skipped the entire while loop. Why? Why did that happen? Well, the start amount is set to be 10, and you'll notice actually that the number of plays is still set to be 12. That's from last time. That's from the day before, right? But that's not really how this simulation's intended to work. I go to the casino every day, having played 0 number of times, and I'm going to start with $2 every time, not $10 every time. So I need to make sure those values are set properly when I start a brand new day, when I start a brand new simulation. Let's stop this debugger, see if we can't fix this. We need to make it so that the number of plays is set to 0 at the beginning of each day. So I put that in the beginning of the for loop, because the for loop represents a single day. That's what one trip through the for loop represents. We need to do the same thing for start amount. And actually, this is kind of a problem that I have with this, the way the simulation is set up anyway. Start amount isn't really accurate down here. This is the current amount that I have, not the starting amount. So I actually think we need another variable. I'm going to keep start amount as it is, and I'm going to make another variable called current amount. I'll set that to be start amount. In fact, I should probably go so far as to set that, well, let's see, I could put this inside of the loop, I suppose. Yeah, I kind of like that, as a matter of fact. And then anytime I win $1 or lose $1, I'm not manipulating the start amount, I'm manipulating the current amount of money I have. This loop should be based on the current amount of money that I have, not the starting amount of money that I have. And then down here, I would look at the current amount of money that I have. Yeah. So the starting amount truly is how much money do I start with every day, and then this is how much money I currently have within a given day. Let's try this again and see if the code works a little bit better this time. I'm going to take these print statements out because I think they're just going to kind of get in the way. I just want to see what happens at the end of every single day. All right, I'm going to try this out. Start with $2, win chance of 0.7, a win limit of 10. Total simulations is 500. And here we go. Now I can see, all right, this is actually looking pretty good, right? We've got changing values. I can see lots of successes, which is kind of what you would expect, although I do see some ruins sprinkled in when I have some bad luck on some days. I would also expect that as well, right? So it's an interesting little simulation that appears to be working fairly well. But we're not quite done with this example yet. We're actually going to keep going and compute. We can actually compute how often we would expect to ruin with this little formula here. So why don't we compare the expected ruin rate from the formula with the estimated ruin rate that we get from the simulation. By that I mean we're going to track how many times we end in success or ruin. So I'll go ahead and make yet another variable for that. Number of successes. Started at 0. Every time I get a successful day, I will increment that by 1. And then when I get down here to the bottom, after all of the simulations are over, I can compute the actual win rate based on the simulations. Or am I computing the ruin rate? I'm computing the ruin rate, not the success rate. So the percentage of simulations resulting in ruin. I'm actually tracking the successes. I should be tracking the ruins. Let me switch this variable around just to make the math a little easier on myself. Okay, perfect. The actual ruin rate is just going to be the number of ruins divided by the total number of simulations. To get the predicted ruin rate, the expected ruin rate, we have a formula. So there's kind of two parts to this formula. You can actually see there's the word if. We've been talking about that word a lot. So let's see if we can code up this math. Right? If win chance is equal to 0.5, we have a different ruin rate computation than if we don't have if we have a different win chance. So I will make a new variable called expected win rate. We'll set it to 0 until we actually compute its value using one of these two formulas that we have here. If the win chance is 0.5, then it's 1 minus the start amount over the win limit. So 1 minus start amount over win limit. And I need to set that to a variable. Go. Otherwise, the formula gets a bit more complicated. You can see we have this alpha term that we need to compute first. So let's compute alpha first, which is 1 minus the win chance over the win chance. And then the expected, I keep calling it win rate, it should be ruin rate. My brain is just a glass half full kind of guy, I guess. The expected ruin rate would be alpha to the start amount power. So in order to do powers, right, this is a question that I get fairly frequently. Alpha, some people think that it should look like this. Unfortunately, that's not going to do it. You can see Eclipse is not happy. We have the math class that's available to us, and specifically we have math.power. So it's going to be alpha to the win rate. I'm sorry, that's not correct. Alpha to the start amount minus alpha to the win limit. And then I believe that whole thing's going to go in parentheses because we are going to divide it by 1 minus alpha to the win limit. 1 minus math.pow alpha to the win limit. Semicolon at the end. There we go. That is kind of a beefy math equation. In fact, I wouldn't even blame you if you broke it up into even smaller chunks. But regardless of how you get there, once we are done, we can finally print out the expected ruin rate. All right, let's give this a try. Make sure this code is working. I'm going to use the same numbers as before. The start amount is 2, the win chance is 0.7, the win limit is 10, and the number of simulations will be 500. All right, it looks like I got a decent value for the expected ruin rate of 0.1835. I mean, that seems reasonable to me. But here you can see the actual ruin rate is 0, and that seems unlikely. Did I really never lose? So, no, I did. Right, I can see that I did lose a few times. So something's not quite right with my actual ruin rate, and this is a classic problem. Consider for a fact that we've, for a moment, we've got two values being divided here. This one is an integer, and this one is also an integer. So we need to cast one of those to be a double in order for this division to work out the way that we want. Since the actual ruin rate should be a value less than 1, it requires a decimal. So let's go ahead and try that again one more time. Win chance of 0.7, win limit of 10, and we want 500 of those simulations. Ah, yes. There we go. So we can see that this time I got an actual ruin rate of just 13%, and I was expected to get 18%. So better than the actual one. The more simulations you have, right, the more accurate it should be, the closer you should get to that expected ruin rate. So let me try 5,000 simulations and see, if that makes a significant difference in the value that we get. It is significantly closer. There's a degree of randomness to it as well, right? So the luck is still going to influence this number, regardless of how you look at it. But yes, this is a neat little simulation, and can be played with in many different ways. If you're a stats kind of person, it could be a fun one to keep playing around with and expanding and working upon. But I'm going to go ahead and move on to the second example. And I know not many people got to the second example, but I love this example so much, and it's actually not that long of an example to code up and walk through. We're going to compute pi by throwing darts. That's the goal of this second problem. Now there is a very particular way that we have to throw the darts. There's some rules that I'll discuss with you here in just a moment after I put in this main method. In fact, I think what I'm going to do is pull up MS Paint and draw a little diagram. The way that this is, the way that this problem works is, we are in a desert island. We have a dartboard that is exactly a unit square. So pretend that this is perfectly square and each side has a length of 1. And then within that, we have a dartboard, which is a circle. So, we know what the radius of this is. It is going to be 0.5. And we also have impeccable aim. And what I mean by that is we're guaranteed to land within this square. We are absolutely 100% guaranteed to land within this square. So I'm going to start throwing darts at this board, right? And I'm going to do it, I'm such a good dart player that I can throw these darts uniformly randomly. So, they're just going to land at random. Am I drawing dots? No, I'm not drawing dots. I want to draw dots. There we go. I need bigger brush. It's just too small. Oh, is this my brush size? There we go. Thank you for that. So I'm going to start throwing darts at this dartboard, and they're going to land, uniformly random across this dartboard. Some of them will land inside of the circle, and some of them will land outside of the circle. So what we need to determine then is how many darts are going to land inside of this circle versus how many darts land outside of the circle. And the reason is that if we take the ratio of area for the square and compare it to the ratio of area for the circle, we end up with pi over 4, which I know I've been very hand-wavy with the math. I am being intentionally hand-wavy because I want to keep this video somewhat brief. I'm hoping you'll buy the premise that if I can compute the ratio of areas between the square and the circle, that I will end up with pi over 4, which I can then multiply by 4 to get me the value of pi. So what that really means is we're going to use the darts to approximate the area of the square and the area of the circle. The more darts I throw, the better of an approximation that becomes. This is a type of simulation known as a Monte Carlo simulation. So this is a classic example of a Monte Carlo simulation. Let's go ahead and hop into it, start writing the code to make this happen. I'm going to ask the user to type in the number of darts that they would like to throw at the dartboard. So let's go ahead and use the scanner. And type out a prompt. How many darts? And then we will read in an integer, since the number of darts will be whole numbered. There we go. I then need to simulate the act of throwing those darts, and I know how many darts I want to throw, so a for loop is a good job for this. I is less than darts, I plus plus. In order to simulate throwing a dart, consider that that dart is going to land in a two-dimensional plane, so I need to randomly select an x-coordinate and a y-coordinate. So the x value, will be math.random, and the y value will be math.random. This works out nicely for our example because remember, this length is a width of 1, so math.random is going to generate values between 0 and 1, right? So I'll generate one random value for the x-axis, one random value for the y-axis, and that tells me where my dart is going to land on the board. The next task that I'm faced with then is to determine, did that dart land inside this circle or not? So we're just going to take the distance formula. I can take the distance from the center of the circle. I know what the radius should be. It should be 0.5. So I'm just going to go ahead and Google distance formula here real quick. All right, my random x value minus the center point squared plus my random y value minus the center point squared. Take the square root. It's going to be some math, but let's go ahead and do it. Distance is equal, double distance rather, should be the type, is equal to math dot square root of math dot how. We want the x value minus the center point, which should be 0.5, 0.5, correct? That should be the x-coordinate of the center. We're going to take that to the second power, minus math.pow, the y value minus 0.5, and we will also take that to the second power. We'll square it. I believe that'll do it for my distance formula. If this distance is less than or equal to the radius of this circle, i.e. 0.5, then we know we've landed inside the circle. If it's greater than the radius, then we know we've landed outside of the circle. So let's go ahead and track the number of darts that land inside the circle. I'm going to make a variable for that. Darts in circle. Set it to be 0 if the distance is less than or equal to 0.5, which is the radius of the circle. Then darts in circle plus plus to indicate that I have had one more dart land within the circle. I'm going to repeat this process, this simulation, until I've thrown all of my darts. Once all of my darts are thrown, then this loop will be over, and I now am faced with computing pi. So the first thing I need to do is compute the ratio of areas. That gets me the value of pi over 4. And I'm saying we're using the darts to approximate those areas. So the number of darts that land in the circle will be used to approximate the area of the circle. The number of darts that land in the square, which, by the way, includes the darts that land in the circle, right? In fact, the number of darts that land inside of the square is just the total number of darts. I said right up at the top that we're guaranteed to land within this square. We're never going to miss the board. So pi over 4 should be equal to the darts in the circle divided by the total number of darts. However, be careful. We once again have this issue of an integer divided by an integer. So let's make one of these a double to make sure that that works. And then last, but certainly not least, I will print out the value of pi by multiplying pi over 4 times 4. So not a whole lot of code for this one, but I think it's a cute little example. Let's try it and see what happens. Let's see if it actually works. I'll start with, you know, a small number of darts. If I type in 10 darts, I get a very bad value for pi, right? It's not enough darts to approximate the area of the circle and the square and properly compute pi over 4. But as the number of darts that I throw goes up and up and up, those will better approximate those areas and get me closer and closer to pi. So, you know, let's do that. Let's type in 100. I mean, that's closer, I would say, but still not great. 1,000. Okay. 10,000. I feel like my math might be off a little bit. I'm getting, this looks like pi over 4. Did I forget to? Did I do it backwards? Should it be the number of? No. I'll tell you what I'm going to do. Well, no. I feel like I'm off a little bit, but I can't quite see what I did. Did I do the distance formula wrong? Oh, it should be a plus, not a minus. I did the distance formula wrong. Ha! All right, let's try that again. 3.6. Okay. Whew. Much closer in terms of ballpark. All right, but also clearly not pi. Here we go. 3.6. If I do 100, I get 3.24. All right, getting warmer. 1,000. Ooh, yeah, looking even better still. 10,000. Still not quite pi, though. Not that classic 3.14 that we would hope for. Whoop, oh, I forgot to hit enter. 100,000. There's 3.14, but then it should be 159. So you can see it's still not quite so accurate. This will be 1 million. I keep hitting the wrong button. All right, 3.14. Let's do 10 million. Oh, and here's another interesting thing, right? 314,159, I believe that should be. But you can notice that it took a little second, right? It didn't pop out instantaneously like it did for the smaller numbers. I'm throwing 10 million darts. The computer is simulating this 10 million times. That's a lot. So yeah, we're starting to see that it's actually taking the computer some time to do this. Let's see how long it's going to take for 100 million. Oh, see, noticeably, right? Noticeably longer. Still finished, 3.1415. Oh, come on, I wanted to see a 5 there. But still, let's try 1 billion. This might be the last one that I try. And while it's running, I'll explain that this starts to become a very important part of computer science, especially as you get deeper into the field. How long things take, how efficient they are, becomes a very important concern of computer science. And a big part of what you'll learn in one of the follow-up classes to this class, data structures, starts to look at this topic in a lot more detail. How we write the code matters, and if we write code that works but isn't going to finish in time, then that code's not very useful for us. So that is something that we have to keep in mind. You'll notice this has been computing, this has been simulating the entire time I've been sitting here talking. Will it eventually finish and give me a value? I believe that it will, but it's taking, oh, there it goes. It's taking a long time, and it's still, I didn't get the 5. Wow. So, it takes a lot of darts for this approximation to get much more accurate than a few places after the decimal, but still a cool little exercise regardless. All right, that's going to wrap it up for the studio today. The other thing that I wanted to mention real quick before I end the video is to talk about the assignment. So in this assignment, we're asking you to play a little game, and one player is going to be the human, and the other player is going to be the computer. The computer is going to play by doing moves randomly, and the human is going to have the option to pick, and interact with the game. And so there's a few things to keep in mind here, especially when dealing with human interaction. Remember that they have the whole keyboard available to them. They can type in anything that they want. So, you need to be careful that if they type in a value you're not expecting, I want a number to be either 1 or 2, what happens if they type in 7? Your code needs to be prepared for that. So that's just something to kind of keep in mind. As with all of the other assignments, I hope that you take a look at the rubric for assignment 2 on Canvas. I've been really happy with the demos that I've seen so far, how prepared everybody has been for submitting this work. It's been really great, so keep it up. And yeah, that's going to do it for this studio review. I hope you all have a great weekend. I will see you in class on Monday when we're going to talk about the topic of arrays. So I'll see you then.